Hello everyone. So today we shall continue from where we left off in the last class, and today we shall complete the remaining part of the second chapter, that is relations and functions, class 11 NCERT or CBSE. Okay, so let us start. Okay, so today I shall start with something called as identity function. Identity function. Okay, but before that I just want to introduce you to how actually you write all these functions and all. So for example, if I write something like this, say y is equals to f of x is equals to x. If I write, okay, so first if I write an equation, say y is equals to x. Now I can write actually this equation in two different ways. See, y is equals to f of x is equals to x. Okay, I can also write this equation in this way, f of y is equals to y. Now you see, this is a representation of this equation. This is also another representation of this, the same equation. Now what is this? Here I am writing y as a function of x, y as a function of x, and here I am writing x as a function of y. Okay, now what is the difference? Here x is input. Now you see, x is input here, basically x is input. Okay, input, and y is output. Okay, input, or you can call it as independent variable. Independent variable, and this y is a dependent variable. Dependent variable, and here y is the input, or this is an independent variable, and x is output or dependent variable. Now you see, so this is a representation where x is input and y is output, whereas here x is output and y is input. Now x is also called as independent variable. Why? Because you can choose any value of x at your will from the domain, definitely, and according to the value of x you will get one and only one value of y. So that means the value of y is dependent on x, dependent on the value of x. So that is why y is also called as dependent variable. Okay, so this is the way you can write. Now I'll show you how actually basically you can write these functions. See, if I write something like this, say y is equals to x, that I have already shown you, so you can write it in this way, y as a function of x which is equals to x. Now if there is an equation, say x square plus 2x plus 3. So now this one also you can write it as y as a function of x which is equals to x square plus 2x plus 3. So this is the way you can write. Or say there is an equation, z is equals to x square y square plus x square y plus x y square plus xy plus say 5. So now this equation also, see, there are two terms, basically two variables, x and y. So I can write this as a say z is equals to function of xy, and I write it in this way, function of x comma y, and then this equation, x square y square plus x square y plus xy square plus xy plus 5. So this is the way basically we write any function. Okay, so now we shall start with this identity function. Now you see, any function, okay, any function, say any function f from R to R. R is R to R. R is set of all real numbers, set of all real numbers. That means its domain is real number and its range also real number. So any function from R to R, from this domain to this range, which is written in the form, say y is equals to f of x is equals to x. Okay, so where x is basically, x is a real number. Okay, so x is the, you know, this the set of all x's is nothing but this R, and the set of all y will be in this R. Okay, so if you write in this form any equation, that equation is, that function is called as identity function. Identity function. So I repeat, any function from this domain to this range, from R to R, written in the form y is equals to f of x is equals to x, is called as identity function. Now any function that you deal with, basically you have to find out three things. One is domain, then range, and then you have to draw the graph. Okay, so I repeat, any function that you deal with, you have to find actually the domain of the function, then range of the function, and you have to draw the graph of the function. So we shall also do the same thing. So now first I shall draw the graph. How to draw the graph? So to draw the graph, you first write the equation. So I write the equation is y is equals to f of x. So you do not need to write f of x, because you know f of x means function of x. So I'll write the equation y is equals to f of x, then I'll prepare the table. So to prepare the table, I do it like this, x, y. Okay, now if I put here 0, if I put x is equals to 0 here in this equation, then I get y is equals to 0. Okay, then if I put 1, then I'll get 1. Okay, then if I put minus 1, I'll get minus 1. If I put minus 1 in place of x, I'll get minus 1. Then if I put plus minus 2, I'll get plus minus 2. Means for plus 2, I'll get plus 2. For minus 2, I'll get minus 2. In this way, for plus minus 3, again I'll get plus minus 3. Okay, so what are the points that we get? The combination of abscissa and ordinate. What are the points? X comma y. So I get these points, 0 0, then 1 1, then minus 1 minus 1. Okay, then 2 2, then minus 2 minus 2. Okay, in this way, then plus 3 minus 3 minus 3, like this. Now because this equation, you can see this equation here, the power of x is actually 1. So if the power of x is 1, then you will remember that this is a linear equation, or this is an equation of a straight line. So to draw the straight line, you need only 2 points. So basically this point and this point, these 2 points are sufficient. But for our convenience, I have taken some more points to make it much more clear and much more convenient. Okay, so what I'll do is I'll just draw in this way. Say this is x, Okay, so this is 0 0, the origin, then 1 2 3 4 5 like this, minus 1 minus 2 minus 3 minus 4 minus 5, minus 1 minus 2 minus 3 minus 4 minus 5, 1 2 3 4 5. Now I'll locate this point 0 0, so that means the origin. So I'll first locate this one, this point 0 0. So this is one point that I have got. The other one, the next point is which one? See, 1 1, this 1 1. So 1 1. So this one, this is the point. Okay, then minus 1 minus 1. So minus 1 minus 1. So this is the point. Okay, then plus 2 plus 2. So this is plus 2 plus 2. Then you can see minus 2 minus 2. So these 4 points are actually sufficient, you know. So these 4 points, I have 5 points actually. This one, 1 2 3 4 5. Now I'll just connect all these points. So if I connect these points like this, I get a straight line basically. So this is the straight line. You can see the straight line is passing through the origin. Okay, so this is nothing but the graph of this function. Graph of this function y is equals to x. Okay, this is the graph. Now what is the domain? Now you can see basically I have taken some integer values for my convenience. Actually I can take any real number. For example, I can take here 0.5, so it will provide me 0.5 here, or 0.9, it will give me 0.9, well 0.999999, whatever. So this will be basically this domain. So you already know domain means all the collection of this x value, or this x value. So that is nothing but the set of all real numbers. Any real numbers you can take as the value of x. Okay, and what will be the range? Range also you can see whatever value you put here on x, you will get the same value on y. So this range is also these are all set. So this is also set of all real numbers R. Okay, so this is domain. We have found range, we have drawn the graph. That's all. Okay, so we shall move to the next function, which is nothing but constant function. Now, constant function. Constant function. Okay. So now any function f from R to R, just like before. Okay, R to R, written in the form, say y is equals to f of x is equals to c. C is any constant value. Its value can be any real number. So I consider that as a constant number. Written in the form is called as constant function. Is called as constant function. Now again we shall find first of all domain. Okay, then range. Then we shall draw the graph. Okay, so we shall find three things. So first I'll draw the graph just like before. So the equation I'll write here, y is equals to c. Okay, now I'll plot the graph. To plot the graph, I'll collect the value of xy, that means the combination of the collection of abscissa and ordinate values. So just like this, just like before. Okay. So this is the origin. This is the origin. Okay. So now 1, 2, 3, 4, 5. Minus 1, minus 2. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. So now see first, what for convenience, actually for convenience I can also write this equation as something c multiplied by x by x, you know. So now put here 1, say I put here 1, so you put x here 1 by 1 is 1, so you get the value of y as c. Then I put here 2, so 2 by 2, then I get here c. Then 3 by 3, 3 by 3, then again you will get c. Then minus 1, if I put minus 1 by minus 1, so that will be 1, then y is equals to c. You see, minus 2 c minus 3 c. So you put any value here, you will get the value of c. So what are the points that I am getting? I am getting first here 1 c, then 2 c, then 3 c, then minus 1 c, then minus 2 c, then minus 3 c. So these are the points that I have got. Okay, these are the collection of abscissa and ordinate. Okay, so let me take, I told you that c is nothing but a constant value, any real number. So let me take it as, say, c is equals to 3. Let c is equals to 3. Let c is equals to 3. So I'll take it as 3. So what are the points that I am getting? 1, 3, 2, 3, 3, 3, minus 1, 3. So like this. So 1, 3. First I'll locate 1, 3. So this is 1, 1, 2, 3. So somewhere here. I get the point somewhere here. So this is the point I am getting. Then 2, 3. You can see 2, 3. So I'll get here 2, 3. So it will be somewhere here. Then 3, 3. So 3, 3 is here. Then minus 1, 3, minus 2, 3, then minus 3, 3. You can see this minus 3, 3. Now you connect all these points. So this is the graph. You can see this is the graph. The graph is the horizontal. A horizontal line or a parallel line to x-axis, and it will pass through y is equals to 3, because the value of c is 3. If the value of c is, say, the value of c is minus 2, let c is equals to minus 2, then it will pass through this. So this will be the graph. It can be any other value, like c is equals to 1, so then it will be like this. So it will pass through c is equals to 1 like this. So its value depends on the value of c. It's the graph. Okay. Now you see, I have told you to write it in this way just because it makes easy for you to prepare to make this table. But actually, if you really look at it, then this is not proper. This is not proper way to write, because if you write the function in this way, then this equation, then this function becomes discontinuous at x is equals to 0, which you will see later on. But this is not the proper way to write. I am still writing it just for our convenience, just to make this table, that's all, just for your understanding purpose, but you should not write it in this way. So this is not proper way of writing, but it definitely helps you to understand the whole thing. Okay, so now this is complete. You have drawn the graph. You can also write like, say, see, now it is discontinuous at x is equals to 0. If you write x minus 2 by x minus 2, then it again becomes discontinuous at x is equals to 2. So that is why I am telling that this is not correct way of writing. Okay, but it definitely helps you understand. Okay, now, so the graph we have drawn. Now, what we'll do, we shall find the domain. What is the domain? So domain, you can take actually any value of x. Any value of x. So this is nothing but R. The set of all real numbers. This is the domain. And what is the range? Range is C. Range is C. C is any real number. But is it the proper way? Is it proper way to write only C? No. Because range is a set. So you must write it like this. So range is this, domain is R, and graph we have drawn. So we have completed this constant function. Now next function that we shall look at is polynomial function. Now see, what is the polynomial function? So any function f from R to R written in the form, say y is equals to, if you write it, y is equals to function of x is equals to a0 x to the power 0 plus a1 x to the power 1 plus a2 x square plus a3 x cube plus dot 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 plus an x raised to n. If you write it in this manner, where a0, a1, a2, a3 dot 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 an, they all means the coefficients, all the coefficients, they are nothing but real numbers. They are real numbers. Okay, and what is n? N means the powers, 0, 1, you can see here. So the n, this power, all the powers, not only n, all the powers 0 to n, this n is nothing but a non-negative integral power or non-negative integral power, or you can say integer, non-negative integer. Why it is non-negative? Can I write here positive? No, I cannot write here positive. Why it is non-negative? Because you can see 0 is also there. So because 0 is there, so I am writing non-negative integers. So these positive integers are also there, 0 and all the positive integers. So that is why I am writing non-negative integers. So that is why your this NCERT book is so good book, very precise they are. Okay, so if you write this equation in this form, then this equation is called as polynomial function. So this is if you write it in this way, then it is called as polynomial function. Okay. Polynomial function. Now again, as you know that we have to find out three things: domain, range and the graph. So now we shall take some examples of this polynomial function. So first example that I shall take up is your example 13 and page number 39. Okay, so I take here example 13, page is 39. Okay, and the equation that they have given is any function from R to R, and the equation is y f of x is equals to x square they have taken. Okay, now you have to find three things, that is, first is domain, then range, then you have to draw the graph. Okay, now you look at this. We have earlier seen actually two functions. One is identity function. So identity function is also one type of polynomial function. Okay, then constant function. Constant function is also polynomial function of only this term. This term a0 x raised to 0, and this one, the identity function, is only of this form, this one a1 x raised to 1, that you can check or just think over it. Okay, now we are talking about x square, means only on this term. So this is the polynomial function. Okay, fine. So let me first prepare the table. So this is y is equals to x square. So if I prepare the table x and y, say x is equals to 0, so then y is also equals to 0. So put simply 0 here, then 0 square is 0, y is equals to 0. Then for plus 1, so 1 square 1, and for minus 1 also, minus 1 square is 1. So for plus minus 1, this will be 1 only. You can see here basically. Okay, then for plus minus 2, it will be plus 4. For plus minus 3, plus 3 or minus 3, it will be 9. Then for plus minus 4, it will be 16. Okay, plus all the terms are plus. So if I now if I now draw the graph, how shall I get this? X okay, this is 1 2 3 4, minus 1 minus 2 minus 3 minus 4, 1 2 3 4 5, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, okay, 18, like this. Okay, so now you can see the pairs. That means first pair is 0 0, so I'll write 0 0, then plus 1 plus 1, then minus 1 plus 1, then plus 2 plus 4, then minus 2 plus 4, then plus 3 plus 9, then minus 3 plus 9, then plus 4 and 16, then minus 4 and 16. Okay, minus 4 and 16, these are the points. So I'll just locate all these points. So first is 0 0, the origin, so this point, then it is 1 1, so 1 1 is this point, then minus 1 1, so minus 1 1 is this point, then 2 4, so 2 4 is this point, then minus 2 4, so it will be somewhere here, then plus 3, it is 9, so somewhere here, then minus 3 plus 9, so it will be somewhere here, then plus 4 minus 4 16, so it will be somewhere here, then plus 4 16, it will be somewhere here. Now you see, now we shall connect all these points. So if you connect all these points, so you get somewhere, so this type of curve you will get. You will get this type of curve. Okay. Now you see this equation, basically this is not a linear equation. So it's the graph is not of any straight line. It will be a curve. Why? Because the power of x is 2. Okay, so this will be the graph. So in case these are not straight line, in that case actually you just 2 points are not sufficient. 2 points are sufficient to draw a straight line, but to draw something like this graph or curve, then you need more number of points to precisely draw the graph. Okay, so okay, fine. So that is why I have taken these many numbers. Actually you need much more number, because you see here also from 0 to 1 also you need some numbers. So I have not taken this for convenience. I have taken only the integer values. So however, this will be the nature of the graph. This will be the shape of the graph. And what is this called? This is nothing but parabola. This is a parabola. Okay. So this is polynomial function. This is example 13. Now we shall take up the next example, which is example 14. Example 14, and page number is 40. Example 14, page number is 40. And the equation is y is equals to f of x is equals to x cube. So now we are actually dealing with this one, x cube. You can see in this only with this term. Okay. So now what you have to find the domain, the range, then the graph. Okay. So let us find what are the okay, so this is x cube. Now this is x cube. So if I prepare the table now, so x, then y. So for 0 it will be 0. Okay, then for plus 1 it will be 1. Then for minus 1 it will be minus 1. So minus 1 cube is minus 1 only. Then plus 2 it will be 8. Then minus 2 it will be minus 8. Then for plus 3 it will be 27. For minus 3 it will be minus 27. For plus 4 it will be 64. For minus 4 it will be minus 64. Okay, so with these many points I think we can draw the graph. Actually you need more number of points, but I am taking only these many points. Okay, so okay, fine. This is y. So plus 1, plus 2, plus 3, plus 4. Okay, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. Okay. Okay, so what are the points? First is 0, 0. So I shall first locate the point 0, 0. That means the origin. this one. Then 1 1, you can see, so 1 1 will be here. Then 2, then minus 1, okay, take it, minus 1 is this one. Then plus 2 plus 8, plus 2 it will be plus 8, it will be somewhere here, okay. Then minus 2 it will be minus 8, so it will be somewhere here. Then for minus 3 it will be minus 27, so you have to go further down and you have to go further up here. For plus 3 it will be plus 27, so it will go outside the board. So anyway, if you connect these many points, so you see, so you get actually this kind of curve you will get as a graph, okay. This will be the nature of the graph of the polynomial equation of the form y is equals to x cube. Okay, now what is the domain? What is the domain here? Fine. What is the domain? Domain is any real number. So this is very clear because you can put any value of x. So from plus infinite to minus infinite. So this is R. What will be the range? You can see here the range is also R only. It can take any value. Range is also R. The value of y. You can see here basically. The range is also R. So okay, fine. So you can write it in this way. In this way also you can write it like, for this one. For this one, the domain you can write domain of the function f or domain of this function is what? All the values of x such that x belongs to R, set of all real numbers, and the range that you can write it as set of all y where x belongs to R, or the value of y, so which is nothing but here x cube and x belongs to R. So this way you can write. Okay, now for the previous one, means y is equals to x square. Y is equals to x square, what it will be? For y is equals to x square, so let me take it as y is equals to x square. So I don't know whether I have told you about the domain or not. So the domain of y is equals to x square, the previous function, example 13 will be, you will write exactly like this. This will be x and x belongs to R, and here y x belongs to R, and here it will be x square. So that's all, domain and range. Now we shall look at something called as rational function. Now we shall look at something called as rational function. Okay. Rational function. So any function f from R to R. Okay, from R to R. Just like before, written in the form f of x by g of x, where both f of x and g of x, f of x and g of x are polynomial function. Polynomial function and g of x, the denominator, is not equals to 0, then this kind of function is called as rational function. Then this kind of function is called as rational function. Okay, so you just note it down. Okay, so now we shall take the take one example of this rational function. Okay, so this is example 15, page number 40, I guess, page number 40. So let me write it. So say any function f from R to R, and it is written in the form y is equals to f of x is equals to 1 upon x. So this is a rational function. You can see this one, this is a polynomial function 1, because what it is, that is in the form, the denominator part is in the form a0 x raised to 0, and the the numerator is in the form a0 x0, and the denominator is in the form a1 x1. Okay, so they both are, so here both numerator and the denominator are polynomial function, and x should not be 0, then only it will be a rational function. Okay, so now you have to find first domain, then range, then you have to draw the graph. Okay, so the equation that is given is y is equals to 1 upon x. So you can see, I'll prepare the table yx. So put x is equals to 0. If I put x is equals to 0, so this is not allowed. Okay, fine, but if you take x is equals to 0, it becomes 1 by 0, so which is nothing but infinite. So it is not determined. Okay, so if you take 1, then it will be 1. Okay, so if you take, say 2, then it will be 0.5. If you take 4, it will be 0.25. If you take 8, then it will be 0.125. Okay, if you take 16, it will be how much? 0.0625. Well, it goes on like this. Okay, it goes on like this. Okay, so if you take minus 1, then it will be minus 1. If you take minus 2, it will be minus 0.5. So you can do one thing, that you can write here plus minus, say plus minus, and here also it is plus minus, like this. So here it is plus minus 1, here also it will be plus minus 1. So here it is again, so everything it will be plus minus, then it is plus minus, then plus minus. Okay, it is like this. For plus 16, it will be plus 0.0625. For minus 16, it will be minus 0.625. Okay, so now let me draw the graph. So So this is the origin. Okay, so now you see 0 is not defined, so I'll ignore this one. So plus 1, it will be plus 1, plus 1, plus 1. So if I take 1, 2, 3, 4, 5, 6 like this, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1, minus 2, minus 3, minus 4. Okay, so for plus 1 it will be plus 1, so plus 1 it will be plus 1, so it will be somewhere here. This is the point. Then for plus 2 it will be plus 0.5, for plus 2 it will be plus 0.5, so somewhere here. Then for plus 4 it will be 0. So it will be somewhere here, the next point. Then you see these, they all are very small values. They all are value. You increase the value of x, so it is a high jump, very big change, and there is a very small change in this one, small change. So here again there is a very big change from plus 8 to plus 16, and here the change is very small. So you can see here. So if you go further, so for plus 8, which is not possible, so it will be again somewhere here. Okay, but it will not be 0. Please understand this one. Then again in the minus side, I'll now take, okay, if I take some more value of, I have to take some more value of x actually. So if I take, say, x and y, say I take the value of x as 0.5, 0.5. So it is, I'll rather take plus minus 0.5, plus minus 0.5. So what it will be? It will be 2, plus minus 2. Okay, now if I take plus minus 0.25, it will be plus minus 4. If I take plus minus 0.125, it will be plus minus 8. If I take plus minus 0.0625, it will be plus minus 16. So the pairs that I got is plus 5 and plus 0.5 and 2. So plus 0.5, for plus 0.5 it will be 2, so somewhere here. Then for plus 0.25, so here it will be 4, so somewhere here. So it goes, so if I actually connect all these points, so I get, see, 1.2.345. So I can take more number of points, so it will be somewhat like this. So this curve in pink color or red color, so this will be the nature of the graph. This is only for the positive values of x. Now for the negative values of x. So first is minus 1, minus 1. So I'll first locate minus 1, minus 1. So this is the point. This is the first point that I have got. This is then for minus 1 it is minus 1. Then for minus 2 it is minus 0.5. So for minus 2 it is minus 0.5. So somewhere here. Somewhere here. Then for minus 4 it is minus 0.25. For minus 4 it is somewhere 0.25. So this is the point. Okay, this is the point. Then for minus 0.5 it is minus 2. Minus 0.5 it is minus 2. So somewhere here. Then for minus 0.25. So minus 0.25 it is 4. So somewhere here. So if I connect all these, now you see this will be the nature of the graph. This will be the nature of the graph. Okay, fine. Okay, so now what you have to understand is that the value of x will never be 0. So that means this curve will never touch this y-axis, neither here nor here. Okay, and this curve will also not touch the x-axis, because you cannot make the value of x is equals to 0. Okay, fine. So actually we shall find it out. So what is the domain? It will never touch y, because at y x is not equal, and it will never touch x-axis also. I'll tell you how. So see the domain. So what will be the domain? Domain will be whole R, set of all real numbers, only except this 0 value. So I shall deduct this one, subtract this, so this will be 0. So this is the domain of this function, rational function, this 1 upon x. And what will be the range? Range will also be the same. This will be all set of all real numbers, and you subtract this 0. Okay, this is the range will also be same. Fine. So now what we shall do is, so that is the reason, you will neither the value of x will be 0 nor the value of y will be 0. Okay, so other than 0 it can take any other value. Fine. So now the next is rational function, and then okay, modulus function. Fine, we shall now look at modulus function. So modulus function. Any function f from R to R, written in the form. How do you write it? So you write it in this way: y is equals to f of x is equals to, so modulus function. What it can take? It will be x. It will be x for x is greater than or equal to 0. For all non-negative values of x, it will assume the value of x, and for x is smaller than 0, it will be negative of x. So that means for each non-negative real values of x, for each non-negative values of x, the value of the function, so for each non-negative values of x, the value of the function or value of y, whatever you write, value of the function is x, and or but, whatever you write it, and for each negative value of x, the value of the function, value of function or the value of y is equal to the negative of x. So what is written for any non-negative values, means for x is greater than or equals to 0, the value of the function or value of y will be x. Okay, and then you see a full stop or, and for each negative values of x, see, for each negative values of x, the value of y or the value of the function is equal to the negative of x, that means minus of x, that you can see. Okay, this is the way it is written. Now, as you know, you have to find the domain and the range, and you have to draw the graph for this function. So we shall do the same thing. First we shall draw the draw the graph. So what is my equation? My equation for, so I'll first take up y is equals to x. So here I'll take only the values like x and y. I'll first take 0. So if I take 0, then this is 0. For 1 it is 1, for 2 it is 2, for 3 it is 3, for 4 it is 4, it goes on like this. But now for negative values of y, what is the equation? My equation is y is equals to minus x. You see, y is equals to minus x. So now what values I'll take? I'll take negative values of, so say this is minus 1. So if this is minus 1, so put what will be the value of the equation? So y is equals to minus of x. So if you put x is equals to minus 1, then y is equals to minus of minus 1. So this is nothing but 1. You can see here. Okay, so this will be 1. Then for minus 2, it will be, if it is minus 2, then minus of minus 2, it will be 2. Okay, for minus 3, it will be 3. For minus 4, it will be plus 4. So it goes on like this. You can take any value actually. Okay, so now that we have got the pair of abscissa and ordinate both for the non-negative values and the negative values of x, so we shall now draw the graph. So first point is 0 0. So 0 0 is this point. Then 1 1, then 2 2, then 3 3. So 1 1. So 1 1. Then 2 2 2 2. So somewhere here. Then 3 3. So somewhere here. So you connect this. So this is 1. Then the next one is minus 1 plus 1. So minus 1 plus 1. So it will be somewhere here. Then you can see minus 2 plus 2. Minus 2, then plus 2. So somewhere here. Then minus 3 plus 3. So this is minus 3 plus 3. So these are, you can see this is the equation. The power of x is 1. Power of x is 1. So these are basically equation of straight line. Okay, so that is why 2 points are sufficient, but we have taken still, so this will be the graph. So whatever you see in red color, that will be the red color part. So that is the graph of modulus function. That is the graph of modulus function. Now what is the domain of this function? Domain of this function, modulus function, domain is R. You can check it. You can take any value of x, anyway 0, 1, or you can take the real numbers actually also, but for our purpose we have taken only the integer numbers. Okay, so this can be any real number, domain. Then what will be the range? Range actually, if you look at it, then from 0 to all the positive numbers. So these are all non-negative numbers. You can say non-negative numbers, or you can also write it like this, R plus, okay, R plus union with 0. Okay, 0, this is union with, so you write it a bit carefully. Okay, R plus means all the positive real numbers and 0, union with 0. Okay, so now so this is all about modulus function. So now that we have we know what is modulus function, now we shall move to the next function, which is Signum function. We shall move to something called as Signum function. Okay. Signum function. How do you write this Signum function? Okay, so any function f from R to R, written in the form y is equals to f of x is equals to. So Signum function, first it will be, there are 3 values that are possible. So one is plus 1. So plus 1, what it will be? It will be for x is greater than 0. Then 0. This will be for x is equals to 0. Then it will be minus 1. Minus 1 for x is smaller than 0. Okay, this is the way you can write. There is one more way. Now that you already know about modulus function, so you can write it in this way also. Say y is equals to f of x is equals to mod of x by x for x is not equals to 0, and this will be 0 for x is equals to 0. So this way, this is also the another representation of Signum function. Okay, so now if you want to draw, so this is pretty simple and pretty straightforward. How do you draw this? So I draw it like this. Zero, 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay, fine. So now you see, for x is equals to 0, y is equals to 0. So 1 point I have got. What are the, if I prepare the table for x and y, so for x is equals to 0, y, the value of y is 0. You can see x is equals to 0, y is equals to 0. So 1 point I have got. So I locate that point. So this is the point that is part of our graph, 0, 0. Okay. Now any value which is greater than 0, any value of x which is greater than 0, the value of y will be 1. So say the value of x is greater than 0, say it is 0.00001, 0.00001 or 00, very small value of x. For that also the value of y will be 1. Okay. Then I am taking more number of points to make it simpler. If it is 0.5, then also it is 1. For 1 it is 1. For 5 it is 1. Okay. For 5 also it is 1. Now coming to the negative part. See, any number, any value of x which is smaller than 0. So if you take a very small value of x smaller than 0, so that is minus 0.000001, say. So for that the value of y will be minus 1. Then for say minus 0.5, so that also it will be minus 1. Then for say 3, minus 3, it will be minus 1. So any value of x which is slightly smaller, even slightly smaller than 0, or which is smaller than 0 will be equated to minus 1, because these three values are all only permissible. Okay. So if I now locate these points 0.00001 and 1, so that means 0.001 means you move slightly towards the right, then its value is plus 1. So plus 1 is here. So the location which will be slightly, so this point right on the y-axis, what is the location? Location is 0, 1. Please understand this. So I'll use a rather white color. Sorry. So this is the location of this point is 0, 1. Okay, but we are locating what? 0.001, which is slightly small, greater than 0. So for this, so here I'll get one point which is slightly right to this one. This is one point that I have got. This point. Then 0.5 it is 1. For 0.5 it is 1. I have got for 1 also it is 1. Then for 5, 1, 2, 3, 4, 5 also it is 1. So somewhere here. So I now connect all these points. Okay. So I get this line. Now coming to the next part, for minus part. Minus 0.001 means slightly left to 0. So it drops to the value of y is minus 1. So if you move slightly towards the left, its value is minus 1. So you get 1 point here. Then for 1 it is, for minus 0.5 it is minus 1. For minus 0.5 it is minus 1. Then for minus 3, 1, 2, 3 it is minus 1. So again, so you connect all these points, you get this one. So this will be the graph of this Signum function. Now there is a small catch. What is the catch? See, here right on the y-axis you have got 3 points. So just concentrate on these 3 points. This one. What is this point? This is 0, 1. And then this point, the origin is 0, 0. And this one, this point is 0, minus 1. 0, minus 1. These 3 points I am getting on the same line. Now can these 3 points be a part of the graph, or can these 3 points be a part of the function of this function? The answer is no. Why? Because you know from the very definition of the function. What is this? For any value of x, for each value of x, you will get one and only one value of y. or you get unique value of y. So you can see here the value of x. So these are all value of x. So here x is same, x is equals to 0, and this is the domain part, okay, domain part, and here y is range part. So in range you have got actually 3 points, 1 0 and -1. Okay, so either this 0 will be mapped to 1, or it will be mapped to 0, or this 0 will be mapped to -1. It cannot be mapped to 1, 0 and -1 at the same point of time. So you know that, so which one from the table? So this 0 0, you can see this 0 is actually mapped to this 0. So that is why 0 0 is part of our graph. So we shall show this with a small solid circle. Okay, but this 0 1, which is this point, and 0 -1 is not part of our graph. So that is why we shall show these 2 points with the help of a small hollow circle like this. So both this one and this one. So please understand this one. This hollow circle just to indicate that these points are not included, are not part of the graph, or are not part of the function. So that is all about Signum function. Now see this one also you can, this one I will show you, this one. See, this one also, they both are same actually, same expression written in different way. Okay, so this way if you write, for example, if you take any value which is where x is not equals to 0, so say the equation is, see the equation I write it as y is equals to mod of x divided by x for x is not equals to 0. So say x is equals to 1, I'll take it as 1, and say 3. 2 positive values I have taken, and I'll take 2 negative values, -1 and -3. -1 and -3. So first plus 1. So if x is equals to 1, then what is y? Y is equals to mod of 1 by 1. So mod of 1 is 1 by 1, which is 1. So I get, if x is equals to 1, y is equals to 1. So this is 1. Then if x is equals to 3, say let us say consider that x is equals to 3, then it will be mod of 3, and here it will be 3. So this will be 3 by 3. So 3 by 3 is again 1. Okay, 3 by 3 is again 1. So if you take plus 5 also it will give you 1, plus 100 it will give you 1. So positive any value it will give you 1 only, 1. Okay, so now I'll take negative values of x. Say x is equals to -1. I'll take x is equals to -1, say. So then y is equals to mod of -1 divided by -1. So mod of -1 is what? Mod of -1 is 1 only. And what is -1? -1 is -1. So 1 by -1 is how much? This is -1. Okay, now see, I get, for -1 I get -1. Okay, for 3 I have got 3. So now for -3 also I'll find for -3. So it will be mod of -3 divided by -3. So which is nothing but 3 by -3. So 3 by -3 is again -1. So you take, now I think you got how actually these two these two representations are same, actually same representation. Okay, and for for x is equals to 0 it is written that it is 0. Okay, so now we shall look at one more function called as greatest integer function. Okay, so what will be its domain? What will be its domain? So its domain is R, whole R. Domain is R. Domain of this function is, domain of f is R. Fine. And what is the range? What is the range? Range, as you can see here clearly, there are only 3 values that are permissible. So what are those 3 values? One is -1, then 0, then +1. So this is the range, and the graph you have already drawn. So now we shall look at greatest integer function. So before I jump into greatest integer function, I just want to recap some basic fundamental concept, basic concept. So this is the real axis. So this is 0, this is say 1, this is 2, this is 3, 4, 5, 6, 7, it goes on like this. Then -1, -2, -3, -4, -5, -6, -7, it goes on like this in both way. Okay, you know, this is the real axis. So now you know that if you go from left to right, from this direction towards this direction, then you will find that there is an increase in the value of the numbers, and if you go in this direction, from right to left, then there will be a decrease in the value of the number. Okay, here in this direction it will be increase, in this direction it will decrease in the value. Okay, so now so from 0 and 1, which one is larger? 1 is larger. Why? Because 1 is located on the right hand side of 0. So that is why anything to the right, it will be greater or larger, and anything to the left, it will be smaller value. Okay, so if I ask you any question, say from 3 to -2 in this, from 3 to -2 in this window or band, in this band, how many integers are there? How many integers are there from -3, -2 to, sorry, from -2 to 3? How many integers are there? So there you can count them: 1, 2, 3, 4, 5, 6. There are 6 integers. 6 integers. And how many real numbers are there? How many real numbers are there? So there are infinite number of real numbers. Okay, real numbers. Infinite number of real numbers in this. So similarly, from say 5 to -4, how many? From 5 to -4. Say from 5 to -4. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 integers in this interval, and there are infinite number of real numbers that you already know. Okay, fine. So already you know that you locate any number like see 1.5. This is 1.5, 1.5, and say any number 2.5. This is 2.5. So if you compare, which one is larger? 2.5 is larger. Why? Because it is located on the right hand side of 1.5. So it is larger than 1.5. 2.5 is larger than 1.5. On the other hand, 1.5 is smaller than 2.5. Why? Because it is located on the left hand side of this 2.5. Okay, fine. So now we shall jump to GIF, that is greatest integer function. Greatest integer function. See, this is greatest integer function. So now, now how do you write the greatest integer function? Any function from R to R. Okay, written in the form. See, it is written as y is equals to f of x is equals to like this. Okay, or it is also written as like this. So this is nothing but GIF function. This is written in the form like this. Okay, now what is the definition? Here the function assumes the value. Here the function or y, the function or y assumes the largest or greatest or largest integer, okay, which are or that are integer that are, okay, integer that is smaller than or equal to x. Now what does this mean? Now it is actually very simple. See, look at the comma. Okay, so here it is the function or y assumes or takes the largest integer, assumes the largest or greatest integer that is smaller than or equal to x. So if you put any value of x, say this is my real axis, so this is 0, say this is x dash x, so this is say 1 2 3 4, minus 1 minus 2 minus 3 minus 4, like this. So see, if I take any value, say x is equals to 2.5, say I take x is equals to 2.5. 2.5 is where it is? It is located somewhere here between 2 and 3. So this is 2.5. So what it is showing? It is the greatest integer that is smaller than or equal to x. So this is the value of x. So x is currently pointing here. So what are the integers which are smaller than? So you can see integers smaller than or equal to smaller than x are, what are those integers? They are, see, it is 2.5, so you smaller than, that means you move towards the left. So first integer that you encounter is 2, then 1, then 0. So I'll write all the numbers 2 1 0 minus 1 minus 2 minus 3, and it goes on like this. There are infinite number of smaller integers than this value of x. So among all these numbers, which one is the greatest? The largest integer is this one, 2. So that is why if x is equals to 2.5, then y will be equals to 2. So this you have to remember. So this is right. Okay, fine. So now we shall take one more value. If it is 3.5, see if it is 3.5, so 3.5 is somewhere here. So what are the integers that are smaller than 0? That will be 3, 2, 1, 0 and all these. So among all these numbers, which one is the largest? 3. So if it is 3.5, it will be 3. It is like that. So now I will take one negative value. Say x is equals to say minus 2.5. So then what are the integers which are smaller than minus 2.5? So minus 2.5 is somewhere here between minus 2 and minus 3. So what are the integers which are smaller than minus 2.5? So the integers smaller than minus 2.5 are, what are those numbers? They are minus 3, minus 4, minus 5, minus 6, it goes on like this. So among all these numbers, which one is the largest or greatest? Which one is the largest or greatest? This one. So that is why minus 3. So that is why if x is equals to minus 2.5, y is equals to minus 3. Now you see the difference actually. So if x is equals to plus 2.5, it is plus 2. Y is equals to plus 2. And if x is equals to minus 2.5, then y is equals to minus 3. It is not minus 2. So remember this one. So any point of time, if they ask you any number, so you just locate that number. Say it is 0.5. 0.5. So 0.5 is located somewhere between 0 and 1. So you locate the point here. And the answer, the value of y will be, just move towards the left. The first integer that you encounter with will be the answer. So if this is 0.5, x is 0.5, then y will be 0. If it is say minus 1.5, minus 1.5 is located here, then the value of y will be, move towards the left, the first integer that you encounter is minus 2. So it will be minus 2. So if x is equals to minus 1.5, y will be minus 2. So this is the way you find greatest integer function. Okay. So now clearly, what will be the domain? What will be the domain? First of all, what will be the domain? What will be the domain of the function? Domain is whole R. You can check it. It's very simple. You can take any value of x. So that is domain. What will be the range? Range is you can see whatever point you take, you will get only integer numbers. Integers are allowed. Only integers. The output will be only in terms of integers. No matter what value you take. So it will be the set of all integers, which is z. The whole z. This will be the range. Now we shall draw the graph. Okay. Now we shall draw the graph. So to draw the graph, first we shall prepare that table. So x, the value of x, then value of y. So you already know that this is 0, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So now if I take any value, say I'll start it from 0. If it is 0, so you already know smaller than or equal to. So smaller than or equal to, what are the, so 0, if you take 0, then smaller than or equal to there is there. So the output will be actually 0. So you can check it. If I increase it slightly, so here I will draw the graph. Y dash. Okay, for 0 I have got 0. If I increase it slightly, say 0.00001, no matter. So if I increase it slightly, still I will get how much? 0 only. You can see, if it is 0.5, then also it is 0. If it is 0.999999999, then also it is 0. Now, from 0.99 you increase it slightly, you make it 1. From 0.9999999, from here you make it to 1. So here it is slight increase in the value of x. So if you increase the value of x slightly, then at 1, if it is 1, at 1, what will be the value of y? It will be 1 only. Because in the definition we have written the value is smaller than or equal to. So what are the, if x is equals to 1, say x is equals to 1. So what are the integers which are smaller than or equal to 1? So equal to is 1, so then 0, then minus 1, then minus 2, minus 3, it is like this. So then among these, which one is the largest? 1 is largest. So if x is equals to 1, y will also be equals to 1. Okay, so if x is equals to 1, y will also be equal to 1. So now again the same thing repeats actually. If you increase it slightly, 1.1, then also it will be 1. Then you make it 1.5, it will be 1. If you make it 1.9999999, no matter how much, it will be 1. Then you make it 2 again. So from here there will be a slight change and here will be an abrupt change. So from 1 to 2. So then again the same pattern repeats. So you can see this is x is increasing 0 to 999, the value of y is 0, output is 0. But here there is a slight increase in the value of x, there is an abrupt change in the value of y. So this is called as transition. This is also called as transition or sudden change from 0 to 1. So here also you can see from 1 to 2 there will be a sudden change. There will be a sudden change. So this way. So now we shall try to draw the graph. How to draw the graph? Okay. So what are the points I have got? I have got 1.00. So I locate this one 00. So 00 is part of our graph. Then for 0.001 it is 0. So that means for you move towards slightly, it is still here. Then 0.5. So say it is say it is 1. 1, 2, 3. It's like this. Okay, so 0.5 also it is 0. So 0.5 is 0. Then 0.99 also 0, slightly left from 1. So here also it is 0. But so here it is, I draw here 1, 2, 3 like this. Minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, minus 4 like this. So see, if it is 1, then it is 1. So if it is 1 at this point, it will jump basically, and here I get 1 point. So I show it with the help of a solid small circle. Then 1.01, it is again there will be a point which will be just adjacent to 1. Then 1.5, so it will 1.5, it is 1 only. You can see. Then 1.99 also. So here just to the left of 2, again I get 1 point. Then for 2, at 2 it jumps from 1 to 2. So you see at 2 it jumps from 1 to 2. So I get 1 more point here. So I can connect all these. Points. So you see already this point. So this point. This I have connected. Okay. So I have connected like this. Now look at this point, look at this point at x is equals to 1. What is the equation? If you draw this line, x is equals to 1, so this will be a parallel line. So parallel or vertical line parallel to the y-axis, that will go through x is equals to 1. So this is the equation of a straight line which is parallel to y-axis and which will pass through x is equals to 1. So now at x is equals to 1, you can see there are 2 points. First, this point is 1 0. This point is 1. So see, I'll draw it down. So this point is 1 0. And if you move upward, so here this point it is 1 and it will be 1. So this is the value of x, this is the value of y. So the value of x is 1 1, y is 0 1. Now from the fundamental definition of function, you know that both these points cannot be part of the function, cannot be part of the graph. Only one point among these two, between these two, will be a part of the function. Now the chart that we have prepared, we know that 1 1 is a part of the function, 1 1 is a part of the function, and 1 0 is not part of the function. 1 0 is basically not the part of the function. So that is why, to indicate that 1 0 point 1 0 is not part of the function, so we shall show it with the help of a small hollow circle. So like this. Okay, similarly the line which is x is equals to 2, x is equals to 2 is a parallel line to y-axis which will pass through x is equals to 2, this point. So at this point also we get basically 2 points. You see, there are 2 points. So one is this point, the other is this point. So that is 2 1, 2 1 and then 2 2, 2 2. So we know that both these points cannot be part of the function. Only one point will be the part of the function. So that is why, which one is the part of the function? This one, 2 2. 2 2 is the part of. So this is part of the function. 2 2 is the part of the function, but 2 1 is not the part of the function. So 2 1 is this point. So to indicate that this is not part of the function, we shall show it with the help of a small hollow circle. So the pattern actually repeats, it goes on like this. Okay, it goes on like this. Okay, similarly now we shall draw it with the help of we shall take some negative values of x. So first I'll start it from this end now. Say this is x and say this is say this is y. So if it is 0, x is 0, then y is also 0, that we have already taken. Now we shall move slightly to the left, that means minus 0.0000000001. So if you move slightly towards the left, so here, so what will be y? Y will be minus 1. So you can see minus 1. So if it is minus 0.5, then also it will be minus 1. If it is minus 1, if it is still minus 1, then also it will be minus 1. If it is minus 0.99, then also it will be minus 1. For minus 1 also it will be minus 1. Now from minus 1 I will move slightly towards the left. So say minus 1.00000001. So for this one it will be minus 2. So then minus 1.5 it will be minus 2. Then till minus 2 it will be minus 2. Then you increase it slightly, minus 0.00001, it will be minus 3. Now you see 0, it is 0. So you slightly move towards the left of 0. Slightly move towards the left of 0, it drops to minus 1. So here if you move slightly, it will be. So this is the point that we have got. then 0.5 also it is minus 1, then minus 1 also it is minus 1, so minus 1 also it is minus 1. So it is like this. Then you move towards slightly from minus 0.1 to slightly left, then it drops to minus 2. So here it will be to minus 2. Okay, then till minus 2 it is minus 2. So till minus 2 it is minus 2. So you just connect this. Now on the y-axis, y is equals to, on the y-axis, that means in x is equals to 0, at x is equals to 0 means y-axis. So this is nothing but y-axis. Y-axis. So there are 2 points you can see. One is this one. So this one is 0, 0, 0, 0. And then this one is 0, minus 1. This one is 0, minus 1. So what are these values? These are the values of x, these are the value of y. Okay. So now you know that from the definition that both these points cannot be part of our graph. Only one point will be the part of our graph. So which point is part of the graph? You can see here, from here also you can see this point is part of our graph. So this point is part of our graph, whereas this one 0, minus 1 is not part of our graph. So to show that 0, minus 1 is not part of our graph, so we shall show it with the help of a small hollow circle. Similarly on, what if you take x is equals to minus 1, at x is equals to minus 1. So this will be a line parallel to y-axis and it will pass through x is equals to minus 1. So here at this point, what are the 2 points that I get? That is minus 1, minus 1. So I get 2 points, minus 1, minus 1. This is 1 point. The other point is this one. That is minus 1, minus 2. Minus 1, minus 2. So you see the same value for x. So only one point, either this one or this one, either this one or this one will be part of our graph. So from this one you can see minus 1, minus 1, this is part of our graph, whereas this one cannot be our part of graph because this is minus 1. See, it can be mapped to only one point, so it is mapped to minus 1, so it will not be mapped to minus 2. So minus 1, minus 2 is not part of our graph. So minus 1, minus 2, this is the point. To show that this point is not part of the graph, we shall show it with the help of a small hollow circle. So the pattern actually it is repeated, it goes on like this. So you get something like this. So this pattern is repeated. So this is the way you draw the greatest integer function. Okay, greatest integer function. Now there is also one more function called as this is also called as floor function. This is called as floor function. I will come to this. There is one more function called as smallest integer function. Smallest integer function. So in that what it will be? It will be just complementary to this greatest integer function. So that means if you provide any value here, say it is this is any value 2.5, then 3 will be the answer. In greatest integer function 2 will be the answer. In smallest integer function, so rather I write it. There is one more function. So this is y is equals to f of x is equals to x. It is also written as this way. And there is one more function called as smallest integer function. Okay, so that is written as y is equals to f of x is equals to like this. Okay, so in smallest integer function, you know that if x is equals to 2.5, then y will be 2, and in smallest integer function, if x is equals to 2.5, y will be what? Y will be 3. So 2.5 is somewhere here. Okay, for greatest integer function it will be 2. For smallest integer function it will be just, you have to move to the right, and the first integer that you encounter immediately will be the answer. So this will be 3. So similarly, if it is like minus 2.5, if it is minus 2.5, then y is equals to how much? You have to move towards the right. So the answer will be minus 2. The answer will be minus 2. So I hope this is clear to you. What is smallest integer function? What is greatest integer function? Smallest integer function, this is also known as a floor function. So I write it here. This is also known as floor function. Okay, floor. I write it here, floor. And if you are familiar with programming language in C, C++, Python, C#, Java, in all these programming language, you will get actually one function, inbuilt function in the math library called as floor, and through this function you can realize this greatest integer function. Okay, and the name for this smallest integer function is ceil function, CEIL. This is the function, and they all are available in C, C++, C#, Java, Python. In all these language you will get this function. Okay, so you can make use of the inbuilt function, or if you want you can write a user defined function by your own. So if you want any help regarding that, you can ask me. I'll make a video on the same. Okay, if it is required. Okay, then the next thing that we shall look at is algebra of a real function. Okay, so we shall look at it as algebra of a real function. Algebra of real functions. Okay, so first operation that we shall look at is addition. Addition of two real functions. Addition of two real functions. Okay, say there is a function f from say x. Okay, fine, take it as like any other letter. So I'll take it, okay, fine, m. Take it as m to r. Okay, this is domain range. And say there is one more function g from m to r. And also remember that here in this case m is a subset of r. M is a subset of r. Okay, m is a subset of r. Then if it is true, then in the function f plus g from m to r, set of all real numbers. Okay, this can be written as f plus of g of x is equals to f of x plus g of x. And here you have to understand that this x, okay, this x is basically a subset of m, a member of this m, belong to this set, x belongs to this set R, m. Okay, this is how you do the addition process. So you have to actually look at only this part. F plus g of x is equals to f of x plus g of x. So what is f of x? This is one function of x. What is g of x? G of x is also a function of x. This is another function of x. So this is one function of x, this is another function of x. And both these functions has been defined. This function f is from m to r, and this function g is from m to r, and m is a subset of this r. So that means m is also real numbers only, subset of real numbers. So this f plus g from m to r, if you add these two from, and its domain is m, range is r, then f plus g of x is equals to f of x plus g of x. So this is the addition. Okay, then we shall look at the subtraction. Subtraction means subtracting one subtraction. So now subtracting one real function from, so this is a real function, this is a real function, so this is like that same f plus g, f minus g. So you write it here minus g in case of subtraction. So if this is f minus g, then f minus g of x is equals to this, the remaining thing will be same. Okay, this is exactly same. Fine. So now we shall look at multiplication. In multiplication, we shall look at multiplication in two different ways. One is multiplying any real function with a scalar quantity, and multiplying one real function with another real function. So first we shall look at multiplication. See if it is multiplication. Multiplication. Say there are these two functions. So f, m to m, g, okay, this is same, and then we can write alpha f. Sorry, this is not required. Only this much is sufficient. Only. We shall, because we shall multiply this function with a scalar quantity. M is a subset of R, real numbers. Okay, fine. So then alpha f from M to R is written as alpha So this is the scalar quantity, or you can say this is a real number. This is a real number basically, this alpha. So multiplying this function with a scalar quantity. So this is multiplication. Now we shall see multiplying this function with another function. Multiplying one real function with another real function. Okay, so now say this is a function, this is a real function, say this is another real function from M to R, and say M is a subset of R. Okay, M is a subset of R. Then f g, f multiplied by g from m to r can be written as f g of x is equals to f of x into g of x, where x is a member of M. X belongs to this set. Okay, this you have to remember. This is multiplying one real function with another real function. Okay, now division. Dividing one real function with another real function. Okay, so suppose f is a real function from M to R, g is a real function from M to R, M is a subset of R. Then f by g from M to R can be written as what? Can be written as f by g x is equals to f of x by g of x. And here you have to remember that this x is a member of M, and g of x is not equals to 0. The denominator part cannot be 0. So this is the way. So this is one real function by another real function. F is nothing but a function of x, g is another function of x. Okay, or you can write it as like f1, f2, that is also fine. So this is just the way you write it. Okay, so this is nothing but division of two real functions. So I think this chapter is completed. In the next video we shall move to the next chapter, that is trigonometry chapter. Okay, fine, thank you.